And welcome back to the next episode in our factory building series. If you remember last time, we were looking at placing objects. So we got our build tool up and we was able to have a look at placing objects, but not in a grid, and that's what we're going to look at today. So to do this, a lot of people I've seen in tutorials use some sort of a gridding object system, and some of them can be quite intensive, and they draw the grid onto the ground. Do we need to see the grid? I'm not 100% sure. That's something we can look into, but I don't think we need to see it, because when we place our actor, we want it to snap to it. So what we need to do is we need to figure out our grid size. Now I'm going to make it easy for myself. You can make this as easy as hard as you like. We have a grid system already here with this prototyping material, and it's basically 1 meter square grids. Now 1 meter in Unreal is 100 Unreal units, and we're going to need to find out where our trace hits and do a little bit of math to work out where we place our object. Now it's going to get a little messy at first, because our objects, it's like our generator here, are not they're not exactly centered in such a way, so it might look a bit strange. But that said, hopefully it will work. And as you remember, we made this new collision box, which we've allowed ourselves to show. Now we know that we can show these. We can actually show them while we're building and hide them when we're done, which will just give us a bit of a perspective on what we're doing. And because of this, if we clear that, we have a line thickness here. So we could make that much wider. I don't know how much, well, a bit too much, but 1 is quite thick. But I do like the default of 0, which is just a really thin wire sort of thing. Just gives us a view of what's going on, and we can play with this hidden in game variable here. And actually, in fact, we can leave it off and just use the visible, like so. So if we leave the hidden in game to unticked, so it's not hidden, and then use this, because we could actually possibly use this for some sort of collision by using generate. Where is it now? Where is it gone? Where's that collision components gone? There it is. Simulation generates hit events, maybe, whilst we're moving things around, or we could just use the general overlap with it, and we can just overlap all dynamic, which is fine. So let's get to what we're really doing today, instead of gibbering on. I'm going to talk about the grid system, and unfortunately it might get a little bit boring because there's a little bit of maths involved, but I do need to explain it. So here is a whiteboard. Wow, that's bright. Here's a whiteboard of what I'm talking about. Now, for now, ignore all the numbers in this grid. What this is say this was our landscape, and it was a 9 square grid. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, which is 3 across by 3 down. Yep. Now, the grid size is 1 meter. So each grid is 1 meter along each edge. Yep. So each square is a meter square. Obviously, you wouldn't have a landscape this size, but this is just for example. 1 meter in Unreal is 100 UU, Unreal units. Yep. So how do we find the grid that we're in? So what happens is we get a trace and it fires somewhere. So let's simulate a trace. Let's get a shape and an arrow. Let's put the arrow there. We'll make it red, just like our nice hits. So we can see, there we go. We have an arrow there. Now, we don't know where that location is in there, but obviously the hit trace returns it. So let's say that that location there is what, judging by this, it's roughly a quarter of the way across. And if I just bring that down just to make it a little bit easier, it's about a quarter of the way across. So there's a quarter, half, another quarter, full, yep. And roughly 50% down. So how does that look? So in here, let's just go back from shapes and put some text. So that hit trace, let's do it in red so we know it's our hit trace, is going to be a coordinate. See, obviously these are meter square, but each meter is 100 units. So that coordinate is roughly 25 units in. Okay, so that would be, as 100 is a 0 base and we're including 100 in it, we had to deduct 1. So that hit trace will be 124. Yeah, we deduct 1 because we're including 100. Yeah, 100 to 124 is 25 steps. Believe me, it's true. 0 base. And from there to halfway, again, this is grid 100 is this corner, and 199 by 199 is this corner. Yeah, because it's units of 100 and we're inside this grid. So we've got 124 by 149, because again 50 units including the 100 is actually 149. Okay, so that's where our trace has hit. Okay, so how do we find what this is? So it's actually quite simple maths. What we need to do is to find out grid number 5. They're not going to be called grid number 5 in Unreal. This was just for your visual representation. It's going to be a location. Okay, we need to know what grid we're in. So how do we figure this? Well, it's actually quite simple. So to know where grid number 5 is, we need to know how to get to these coordinates here. And that's quite a simple process. So we've got these coordinates. Yeah, what we need to do is 124, and let me see, I don't know if you use this symbol, so it's not actually on my keyboard. I'm just going to show you the mathematical symbol. So it's divided by, that's the mathematical symbol on here, but it's not the real divide by symbol. It's not actually on a UK keyboard. That's strange. Okay, so divided by 100, which gives you 1.24. Okay, so that's not giving us our answer. But now what we do is we round, let's spell it, round down to our nearest whole number. Yeah. So the nearest whole number rounded down is 1. Yeah. And then to get our grid position, we're working just on the X at the moment, the 124, yeah? The 124 part of the host of the hit. So 1 times 100 equals 100, which matches our 100 there. And we do the same with our other number. So we've got 149 divided by 100 equals 1.49. Then we round down, which equals 1, and then we times that by 100 again, which equals 100. Obviously we're doing the simple one first. I'll show you a much more difficult one in a minute. Well, not much more difficult, but a different one so you can understand it. So now that gives us 100 by 100. We now know where the beginning of the grid is. That's the start of the grid. It extends to there, to there. We actually don't need to know the extents of this grid. It's just that I've just put these in as a visualization purpose. So this grid starts at 100 and 100, and it goes to 199 and 199. And just to show you a slightly different one, this is in the same 100 across, So X is 100 units, down is 200 units, yeah? So for each square meter, it's 200 units to match this, yeah? 1 meter is 100. So this grid here is located at 100 by 200. Okay, so in the if we change the hit on here, let's just move that up there for now, and I'm going to get some text, and I'll put this one in blue. And so we're going to do one that is a little bit more weird. Let's do it quite extreme, actually. So we say 190 by 260. Okay, that's where we're going to put our trace. So let's draw in our trace, and the trace is, what should we say, 190 by 260. So this one's going to come in, and it's going to be about roughly about there. Just a rough guess, yeah. We'll change that to blue. Okay, so we're roughly at that point, yeah. So we're talking 190 units across. So if we measure from there all the way to there, it's 190 units, and if we measure from there all the way down to there, it's roughly 260. We're gonna go with that. So same maths. We take the X first, so just so X coordinate, and we'll do this one as, oh, we've done there, Y coordinate. Okay, just so we know what both of those are, let's put this over here. Okay, so we now have our new coordinates, so we do the same thing. So our X coordinate will be 190 divided by 100, which equals 1.9. Yeah, you with me? And then rounded down equals 1. Yeah, so again we're still in the same 1 across, and then we times that, multiplied by 100 to get our units. So column 0, column 1, column 2, yeah, row 0, row 1, row 2, and that's the numbers we're most concerned about. So we times that by 100, which is obviously 100. So our X coordinate is 100, and our Y coordinate is 260. Okay, divided by 100, again, because that's our grid size. We want 1 meter, which is 100 units, which equals 2.6. We then round down, which equals 2. So 2.6 rounded down to the nearest whole number is 2, and then we times it by 100. Well, I'll use the actual computer symbol just so you can see it properly. 200. Oh, 100. Putting the answer in too quick, which equals 200. So you can see now how this math's working by rounding it down and timesing it back up by 100. Yeah, we get our absolute start value for the grid we're in. Okay, so now we have that rounded down, we have 200, so our coordinates will be 100 by 200. And if we look in the box, we are in box 100 by 200, which matches. Yeah, that's how we get our coordinates. Now, how do we figure the center point? Now, this can be a little bit more complicated because you need to make all your objects, let's go into Unreal again, of the correct size. So it might be a wise idea in the generator itself to store a variable, and we need to store a variable which is going to hold grid size. Okay, so now this object we know is 1.5 deep, and it's 2 wide. It's 1 wide, sorry. It's actually only 75 wide, but to make it fit to a grid, we have to make the object think that it's 1 meter wide, and because it's 1.5 this way, we need to make it think that it's 2 meter wide, because the pivot point is in the center. Okay, so as the pivot point's in the center, we need to work out where that center is. So all we need to know in here is what the grid size is. So let's set this to let's see if there's a vector 2. I don't think there is vector 2D. Oh, there it is. There it is. We'll make that visible. Right. So we have a vector 2. Let's compile. And that lets us work these out. So this is 1 grid wide and 2 grids long. So as that's 75 width, so 0.75, we're going to take up a whole 1. Have to round it up to 1, yeah, so that it fits our grid. We're not going to scale it or anything. We just want the object to align to the grid. Now the depth of this object is 1.5, which exceeds the 1 meter square. So we have to tell it that it's actually taking up 2 meters squared. Okay, and that's what this is doing. We're taking up 1 grid wide and 2 grids deep. Yeah, we don't need to worry about the height. We're not going to place things on top of each other. So all we need to know is its 2D area, as if it was just in a flat grid. Now what we could have done is this box collider that we're going to use, or may not use, for the extents of where we can actually build. We could have used some maths on that. It's obviously already in 50% increments. It's really strange the way this works, isn't it, these box extents? I'll have to look into that and see why this is such as it is. But yeah, we may use that, and the location I do not know, but for now we'll just have this grid size vector. So we know it takes up a 1x2 grid. So we need to find a way of placing that within a 1x2 grid. Now first, what we're going to do is just get it to place in the grid. Yeah, so using our math here, we need to find a way to round these down and do everything we need to do with this mathematics so that we get the grid area. So the maths is simple. Divide by 100, round down, divide, and then times by 100. Yeah. The reason divide by 100, why bother with the 100 bit, is because you need to use the round bit. Otherwise, you're going to be just using strings just to, try and grab the left-hand side of this. There's no point. Round it down, divide, round it down, multiply. You've got your grid. Okay. You can also from that deduct any position within that grid, because obviously you know that the extents are 99 more than the start, because this is inclusive of that. You got 99 plus a 0 box is 100, isn't it? So I hope you understand that. Some people don't understand the 0-based coordinate system and an array system, that 0 counts as the first instance. So this number is always 1 less than it should be because it includes the 0. But hopefully you kind of get the understanding of that. Anyway, let's come back out to Unreal. So into our builder. Now that's our spawn new build. Let's close that because we don't need to mess with that. So this one, sorry, where is it? Here we go. This one here now sets the axis location and rotation. Yeah, I'm going to reset that to 0 so that the rotation is correct. We're not going to bother with sweep hits at the moment. We may start using these and see if there's any hits on the collision boxes, and if there is, then we can detect if there's an object in the way. Or like I said, it might actually be best to have some sort of storage array It just depends on the size of the map and how effective that would be. We'll see. So anyway, I have a habit of just compiling everything these days. I think it's because I get a lot of crashes with Unreal when I start doing some more intense stuff, so I just like to save things off. So in our BPC tool builder, we now want to disconnect our location. Okay, for now. Yep, we'll leave the target in because we do need the target, so we're just going to place this up here for now. We need to get done our maths. Yep, so we need to break vector. Okay, what this does is separates our values into separate ones, so you haven't got them all just in the vector there. You can access now the X independently, the Y and the Z. Now the Z we need to keep, yeah, and that's never going to change. Yeah, so we need to bring that out and we need to make a vector. Now this is probably going to go in the wrong socket. Yeah, it has. Make sure that's in the Z. Okay, so this then comes out the end when we remake this vector, and this is what's going to go into the new location. So we can rehook that book up actually. So now we need to put our maths in. Now I think we can use a function for this, so let's do that. And this is going to be calculate grid. So what do we need to know in calculate grid? Well, we need some inputs. So our inputs are going to be, again, a vector vector 2 we'll call it, and it is going to be a vector 2D. So vector 2D, vector 2D. Oh, let's do it again. Vector 2D. I hate it when it does this. Vector 2D. There we go. And it would help if I could actually spell vector 2. Okay, so all we need to know is the vector 2 location. And what are we going to output? We're going to re-output the new vector 2. There we go. So all this is going to do is return our grid. So how are we going to do that? Now all we do is look at our maths again on this board. We divide by 100, we round it down, we times by 100. Yeah, that will give us our zeroed grid position. So it will move from that spot to there, that spot to there. Sound pretty straightforward? We'll see. So if we split the struct pin, it makes it a little bit easier to use. And the same here, split the struct pin. And all we need to do from here is do all the maths. Now I could actually make this even more simpler, but for now I'm just going to do it this way, just so you understand. But I could actually make it simpler by having one function that does these two separately, which would probably collapse it to afterwards. But let's do this first. So we come out and we want to do our first operation, which is divide. Yeah. Okay, divide. Actually, I'm going to use the safe divide. Now, if you look over this, it will return 0 if the B. To be honest, no, we're not going to be using 0. That's no. No, we'll just use divide. We don't need to. We're never going to be using 0 there. Okay, so we're dividing. What are we dividing by? Because our grid is 100 units, we're dividing by 100. Yep. And we need to do that on both. Yep. Then we need to round down. Now, I'm not sure whether just converting to an integer would have done that, but let's just use the round and to the nearest integer. I'm sure there's a, I can't remember what it's called in this. It's not round down. Bear with me a second. Okay, brain went blank then. So it's a traditional, I believe C++ roundings where you've got ceil, C-E-I-L. If I type it in, should give you ceiling, which would be the higher number. So it rounds up towards the positive number, up to the next integer. Yeah. So 1 point whatever will always become 2. Yeah. As long as it's not 1.0, it will be 1. But we want the opposite way. So we're using floor, and that goes downwards to the previous integer. So 1.6 becomes 1. So anything, regardless of whether it's past the halfway point, it will always come down to 1. And we want to do the same on both of these. So we just floor them both. Okay, so that rounds us down. Now we've rounded down, we just need to do our multiply. Now, unfortunately, it casts, when we do floor, it casts this to an integer. So we will just have to convert it back, but it's not a problem. So we multiply by 100. Yeah. And then we have our value. So we need to plug these in, but it needs to convert back to a float. That's not a problem. Let's use one of these automatic conversion nodes. Yeah. So just like in our whiteboard, so we take the coordinates x and y, divide them by 100, round them down to the nearest whole number, which is an integer, and then we times it back by 100 to get our value. Yeah. So we take our value on x, do the same on y. So I might make this little one into a function, make it look nice, and we divide it by 100, round it down, times it by 100, and send it back out, and that will give us our location. Now, are you going to trust me to say that this will just work? It should do. I've done this many times before. So let's go back to our event tick for where this is all happening, bring it across. So now we have our two values, and we can just plug in our new function, calculate grid, there. Let's break that. Forgot about this. We're going to split the struct pin. I could have probably had them separately. Bring this into the middle. Yeah. Weird the way that works. Let's bring this up. Sorry, I just tied it up a little bit so that it's a little bit easier for you to read. Now, I was considering putting some of these projects, but obviously I can't do the past ones because I've already modified them. But if anyone wants to put a note in the comments whether that would be helpful to them, to store the incremental projects as we go along, so that you can download them at each stage, so you're not too far ahead and get confused if you get a newer one. So you could do one at each stage. Just let me know and I'll see if I can provide a way of doing it per episode. But right now I can't go backwards, unfortunately, but let me know in future if any of this helps. Anyway, so we get our vector from our location on our trace. Okay, so we only want the x and y. So there's the x and y. The z will go straight through because we're not changing that. It does its math and then comes back out as the new. Yeah. And then replace it like normal. So let's hit compile and save on that and see what happens. So if I hit play, hit 2, and as you can see, it's moving along the grid perfectly. It looks like this material doesn't actually line up with the actual grid, or it could be something to do with our positioning already of our object. Yeah, it could be. That's interesting. What I'm going to do, I'm going to test that fact now. You can fast forward through this bit if you want. I'm just going to create a cube, and I'm going to place it. Cube, bring it up, and I'm going to place it. And let's do that first so I can bring it a bit closer to me, and then bring it across. So if I put it there, and I want to put that at around 900, and I want to put that at round number 700. Yeah, that cube isn't. Oh no, it is. It's lining up at the center. It's lining up at the center. There. Okay. Oh yeah, yeah. So is that. I can see it now. Yeah, I can see it. It's lining up. It looks like our object is not quite centered properly. Okay, yeah, I've seen what I need to do. I need to do a bit more alignment on that, so that it's right. But it is, as you can see, it's landing in the center. Okay, but that's not quite what we want, is it? We don't want it to land in the center. We want it to land in the middle of its grid, or in the middle of its set of grids. If it's more than one cube, it needs to land somewhere in the middle. So we can see that's working perfectly. The center of this is in the correct place. It's just for some reason my pivot's in the wrong place, which I never checked actually. I could have sworn I did, but let's have a look at that. Yes, our pivot is 50 off center. Which means if I zero that, oh, not that one. No, it's not actually. It's location 0. It must be just down to the way the scale works on here. But it does look like it's off, doesn't it? But it's going by the center of the scale. Okay, and we're extending the center of that scale. Yeah, so we'll ignore that for now. We'll probably create a better version of this, but for now, this will work. This will definitely work. So we can see our grid location is working. Based on where that cube's coming, we can see where it should be landing, because that's our zeroed position. Okay, now I'm going to turn my traces off now, because I'm happy that that's working. So come into the tool, into the first person, and it should be in there. Turn our debug trace off. Okay, and then there we go. We know it's working, so there's no need for me to debug it, and we know it's centering correctly. Yeah, I understand it. It's centering perfectly on that object, isn't it? Yeah, it is. It's only because I extended the bounds out. So that's fine. That's working exactly as I want it to. Okay. So how now, as it's centering on one of these, we can't visually see it on this. Do we want it centered on there? No, we don't. Because we want it to line up inside a grid, not overlapping two. So that's going to involve a little bit more maths. Now, I haven't pre-thought this one out, but it's there in my head. So I haven't got a nice whiteboard like this one to show you. So let's work this out. Okay, so let's go back into our calculate grid. Now, what we want to do is we need to get the actors grid size. So we need to add in here a new input, and again this is going to be ooh, I knocked a key then on my my little mini keyboard, and it's just come up as D. So it's grid size, and this is going to be a vector 2D also. Yep, and we can split that one as well. Just makes it easier. I could have just put 4 values in, but this helps keep it tidy. So let's, for now, move this up. We don't need to output the grid because we're doing all the maths inside here, so we'll just do all the calculations extra. We need to work out now where on a grid this would be. So if we think about it logically, if we take this as an example, we've now got this position, yeah, for this grid. So we want it centered on this, okay? So if it was a 1 cube object, it'd be centered on this. So we need to work out its grid size, which we've got, yeah, a grid size of 1 by 2. So we now know that because it's 1, we need to put the center halfway between this point, which we can easily work out with a value. It's 49. So 100 to 199, the halfway midpoint is 149. But it's 2 meters this way. So we need to form a calculation that works out that 2 gives us this same value here, yeah, so that it's halfway between the two. But we obviously need to take into account if it's 1, it needs to be here. So how do we work that out? But it's basically easy. We've already got 100 units here, yeah. So what we need to do is figure out where the center point is and then times it by our grid size, yeah, and then we need to deduct it from the position. So let's see how we can work this out. I'm doing this on the fly actually, so I have done it before, but it was a long time ago. So let's see if we can figure this out on the fly. So let's get the x calculation correct, and once we've got one correct, we can get the other one correct. Yep. So how are we calculating the middle value? Well, we know the middle value is 49, so we need to add 49, but we then need to multiply it, yeah. So the middle value needs to be multiplied by the grid size. So if it was a 2 grid, it'll be 49, yeah. Well, sorry, a 2 grid, it'll be 49 times 2, but the problem is then we get an erroneous value, don't we? Because we're going to be short by 2 when we get here. So we need to use the 50 base, I would think. Let's have a look. So we've got a grid size of x, and we know our x is 1 on this. So how do we find out halfway point? It will be, let's disconnect these values for now because it's going to come out over here. So we need to get this value now and figure out how far further along the x is our center point. So to get our size, we need to a multiplication. Multiply 50. So for each x value, it is 50 units to its halfway point. So we now want the 50% value, right? So whatever that is, 1 times 50 is added. So we get the 1 times by 50. That's how many extra units we need to add on, and we add that to our x value there. So we need to bring out an add, yeah, bring that into the top one, and then that one, sorry, in the bottom one, and then that one into the top one. We're not going to do y yet, and the reason is I'm going to remove this and condense the one lot of calculations into another function. Make this a hell of a lot more easier. So we now know that 1 times 50 is 50, and that's the halfway point. We're now going to plug this. Now we're going to plug this into the X, and we'll just leave the Y as it is for now. Okay, and we'll go back in, and then we'll hit number 2, and now our X value is centering. I think I made a boo-boo there. Put them back to front. The X value is actually there. So that should have been 2 and Y should be 1. So come back and just double check our X value again. Yep. Let's do that. Put it in. As you can see, it hasn't done anything. But that's because it was kind of right anyway. Because the X value was perfect anyway. Yeah, the X value was actually already in the middle of 2 because of the length of it. But now let's do the Y value in the same way. For now, let's just put it in here, and then we're going to condense this down. So we'll do the same with Y, and this time we need to possibly deduct the value. So let's just do our multiply first and do the same by 50, and then we need to possibly deduct this rather than add. So let's try that. So we'll bring this value out, and we're going to say subtract. There we go. And we're going to subtract this value, and then we're going to add that into the Y. Okay, it's a little bit crisscrossy, but that will be solved in a moment. So let's see if that works. I might be wrong. It's been a while, and it hasn't done anything. Why hasn't it done anything? That's because we're not doing any maths at all. Here comes in another one of my little problems of doing things, is the tool base. Come back to our builder tool and go to Rentic and supply grid size. Yeah. So we need to plug in our grid size. Does help, doesn't it? So we can drag this out and get grid. We don't know about the build out and its grid size. Interesting. See, this is where things can get complicated. But right now, what I'm going to do is I'm going to explicitly change this class to our BP generator base. Okay, now this is wrong. Okay, and the reason it's wrong is because everything is going to be a generator class. But what I'll have to show you eventually is all actors are going to have to come from one class. Yeah, so then we can, the base information that's in there we can always grab, and that will be a base build object or something like that, and then from there I'll have the generator class be a child of that, and there could be other childs of that go to different directions, but it will always give us the base important stuff. So now I can drag off there and get the grid size. So there will be some changes to the objects at some point, because obviously we've just been throwing things together and just working things as they go. So now we've got the grid size. Let's see what that does to our game. So hit 2, and there we go. Look at that. It's now pretty much centered where it should be centered. Well, the width is centered, but the length, not quite so sure. Because of the size of the object, because it's not exactly 2 meters, it's looks like it's centered across the objects again. That's the problem, is because I keep looking at this. Yeah, I'll keep looking at the bounding box. Ignore the bounding box and just look at the object itself. It's centered between 2 parts of the grid. Now, we'll be changing that, and we can change that quite easily by moving the base object forward a little bit from its center inside the generator. So the position of this, I want it to be, as it's 1.5, I want it to be maybe 0.5 forward. So minus 50. That might be too far. It might be too far. I'm going to switch off this bounding box for now. Again, I'm not using it at the moment. Let's turn that off to visible. And let's see where this shows up. So play will help. Okay, so again, it's centering on the one axis, but it's not centering on the other. It looks like it's about a quarter off, maybe a bit more. Again, that's down to the dimensions of the actual generator. I could actually make the generator 2 meters long, and then it would be compliant, I would think. So if that's 2 meters long and it's at 0 position, it's centered, and let's just see how well that fares now. Number 2. Yeah, there we go. That just shows how perfect it is now. So as we shorten it down, we need to add 50% of its scale back onto it. So I could possibly put that back down to 1.5 and then move this by minus probably 25 or something like that, which is half of its length that it's just lost. Yeah, that's the theory. And then hit 2, and there we go. Perfect. Look, lines up with the front. Got it. So that's what it was. I was taking into account the full bit that was missing, but it's not. It's 50% because it's centered. I don't need to explain it. The positioning of all the objects, you do need to have some sort of discipline, so that the object does work how you intend. Now this is kind of strange, because to say this grid doesn't line up with the grid that's on the grid that's on the material. As you can see, it does on there, it does on there, but oh yeah, it does. Yeah, it does. Sorry. Yeah, it does actually. It lines up quite perfect. Look at that. But it looks like it's a grid behind, doesn't it? Now, why is it a grid behind? It looks like the width grid is a whole grid behind. But that's strange. Let's change them both to the same anyway, and we'll see. So, build a tool. We now need to, I wonder if we bring negative values. That might be what it is. We'll have a look at that in a moment. So first thing we want to do is come back to our calculate grid, and we're going to change this to just one function. Let's change it to attach grid, or attach to grid. So to attach to grid, we could do this by, we're only going to do it by one position, and that's going to be a float, and grid size, grid size, and that's going to be a float. Okay, so what we do, if we go into our calculate grid, we just want one lot of this information, and that should have been add. That's probably why. Yeah, I'm deducting, it should have been adding. So if we go add, and let's just make sure this works first before we carry on. For some reason I was thinking subtract, but there we go. There we go. It's inside the square we want. There we go. And it's inside that square. Yeah, spot on. Absolutely spot on. So there we go. Knew there was something silly. So all we need to do now is, instead of having this do this twice, we can have this do this once in attached to grid. Yeah. So all we need is this piece of code here and the multiply based on the grid size. So if we get all this, and what happened there? I've not seen that before. Control C. Oh, I didn't know. That must be OBS. I didn't know it did that. That's useful. So select all those and that, copy that, bring that into our new function attached to grid. I'll keep right clicking to paste, but it's not in here, is it? And then all we need to do is attach all this together here. We can condense it down as much as we can to make it so it's viewable. There we go, and there, and grid, and then we just need to output it again. So our outputs we need are, so if we highlight this again, just our vector, don't we? So shall we do them individually? No, we've got to, yeah, we've got to do it. So output position, just call it that. So it's not a vector because it's just the one float, is it now? So now what we've done is we've condensed all that code into one simple little function, which we just call twice. So in our event tick, we will get rid of the calculate grid, and we will just go attach to grid and attach to grid, both of these. So bring that one in, and let's space these out a bit. So if we grab these, just bring them across a little bit, because what we're going to do is, just to make it a little bit easier, we're just going to do sequence, attach to grid, and then break the vector there. The make vector is going to come further down, so we need to put X into one, Y into the other, and we need to split this one and the X grid into there and Y into the other, so that it just does the same thing but does them separately instead of having duplicated code. We could bring our break back here, probably there, tidy that up a bit. So the first one is that, then that. I know there's a lot of nodes running around, but it all gets to where we want it to go in the end, doesn't it? And then we'll bring this to our third one, where we remake our vector, and we remake our vector. Oh, that gives us a problem. It gives us a problem because of the remaking of the vector. So we'll do those one after the other. Let's get rid of, oh, so I can grab that. Yeah, I can. Let's bring that down. We'll tidy this up. And it's going all over the place, look. Oop, caught it wrong again. Move this down. Let's bring it there. A bit more tidier. Okay. In fact, we won't use a sequence. Let's get rid of the sequence. We'll just do it one after the other, as we've had to do it this way anyway, because of the making of the vector. Let's bring that in. Bring this back up. Just bring this across a little. Move it across so we've got room to make the vector. So our X position, make vector. Doesn't show up there. There it does. To here. Just drag that in there. And our Y into there. And our Z will come from here, from the original break vector. It's a little bit confusing, this, I'm afraid. But basically, I'll just explain it so it doesn't look too much of a pain in the backside. Okay, so I'll just explain what I've done. So what I've done is condensed, instead of having two lots of calculations going on through here, blah, 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 yeah, I've condensed these into one because they both do the same thing, yeah. So this will calculate just one, either the X or the Y, and then we just run it on each. So we choose that in the vent tick. Oop, back here. So we break the vector, we set the X position and the X grid size, and we calculate the output position from our new attached to grid. And then we do the same with the Y. We send the Y position and the Y grid size into the same function. So we get two outputs, one for the X, one for the Y. We then rebuild them all, including the old X, the old Z, sorry, and throw that back into there. Yeah. And all that does, when we compile it, is exactly the same as what we had before, just all in a more compact way. There we go. Always on an edge, yeah, and always in the center of a square, not now sort of on that convergence right there. See, can't even force it now. As you can see, that's now on a meter grid. Yeah, even though it's a 2 meter long object, or it's bound to 2 meter long, it's actually on a meter long grid. Yeah, so I don't have to jump 2 meters to put this. So there we have it. We have a grid placement. So I was a bit messy on that one. It was a long while since I've done that, and muddling up the maths a little. Well, not muddling up the maths, just getting a little bit confused to what I was doing. But yeah, there we go. And then we can still click and place. Oh, and look at that. Yeah. Can you see it? Can you see what I see? The only problem is now, at the moment, is it's not doing the collision detection. But we can do that in the next lesson. Episode? I don't know what to call them. As you can see, perfect. Now, I might actually make this a meter wide, just around the corners or something when I make the object, just so you can actually stack these up. Or actually, like, you know, having a little bit of a gap there, it's not going to cause too much of a problem, is it? If I turn off the, no, you can't get through anyway. You can't get stuck. So you could have, you know, a whole bunch of generators here. But we'll see. The models haven't been made yet, so it's one of those things. Another thing we need to start looking at some point is the save game object. Now, the only problem is with the save game object is I would like to throw it in early, but it could have an impact on changing it later on down the line if we change anything in the game. It would be good to have the save game object so we could actually throw a few things in so we could quickly go back in and test with. So I might have a look at that and do that possibly on the next lesson, actually in the next episode, sorry, so that we can see when we've placed things how that works. So yeah, no, so we'll do the collision first, and if we can squeeze that into the same episode we will, but if not we'll do it straight after. We'll look at saving what's on our screen, because I'm going to have to do the modification, like I said, to the base object that can be placed, and then we need to derive from each object as we work, and it may break a few things as we go, but hopefully they're not going to be too serious and we'll be able to fix them. So yeah, let's go from there. Anyway, so we've got a working grid system, and you can see we can place. Perfect, eh? But look at that, we can still line them up to the next grid. Now quickly before we go, we could actually, if we wanted to, have a switch to turn the grid system on and off, or the way Satisfactory does it is you can place things anywhere and you can aim at objects to grid them up, or you can hold down the control key and it will use the grid system. Don't think I'm going to go that complex at the moment, because I think it'd be just easier if we just use the grid system and get rid of this calculate grid, because we no longer use that. So let's delete that. We'll leave it at that, as I said about 1,000,000 times already, and we'll move on to the next episode. And yeah, we'll have a look at collisions now. The collisions one could be a bit finicky. I'm trying to find the best way around it. Now, it might mean changing back to the old visibility system of a trace, so that we just can't place on the object that we're aiming at. But I would like to overlap the object, mainly because I would like to see if it's overlapping an object, get the location of that object, and adding extra to it depending on where I'm pointing. So if I'm pointing sort of this side, it will appear over here. If I'm pointing more to this side, so if I see these squares around the edge, if I'm within that sort of bounds, yeah, it will jump to whichever position. And if I prioritize the right and the left, so these 4 squares, it'll jump to there, these 4 squares, it'll jump to there, but these 3 squares here and those 3 squares behind. But we'll see how that works at the moment. I'm not 100% sure how we're going to use that, but anyway, we'll see you next time, and thanks for watching. Bye bye.